Okay, so good day, participants. This is Satoshi Murao from Daiichi Institute of Technology. My affiliation is called Institute, but actually it is a small university located in Kirishima City, Kyushu Island, southern part of Japan. Uh, Today, I'm going to talk about small-scale mining. I am delighted to be here to talk with you. And in this opportunity, I would like to express my sincere thanks to Kyushu University for giving me such wonderful opportunity. Okay, so let me talk about small-scale mining. What it is? It is a type of mineral recovery by deprived people with rudimentary tools and instruments. In case of gold, it is called artisanal and small-scale gold mining, ASGM in short. I have studied ASGM for more than 30 years. My first encounter with ASGM was in 1987. Before joining Daiichi Institute, I was working for the Geological Survey of Japan. I was a governmental geologist, and my first mission in 1987 was to visit visit several gold mines in the Philippines and to work with Filipino officers for the gold exploration. As specifically, I worked with staff at Mines and Geosciences Bureau. And it was December 8, 1987. And in the evening, I was walking around the mining area, and I encountered small-scale miners. Locally, they are called pocket miners. Anyway, I started to study ASGM since 1987. Okay. So the title of my presentation today is Mercury in and around artisanal small-scale gold mining, observations towards better environmental management. To begin, let me explain what is artisanal and small-scale gold mining, ASGM. ASGM is a type of gold recovery where those who do not belong to registered mining company, they use rudimentary tools without scientific and technological knowledge and skill. And basically, they are digging two types of gold deposits. One is placer, which is shown on the left, and the other is hard rock, which is shown on the right. So when they mine placer gold, they scrape gold-bearing mud or sand, and they bring the obtained sand and mud to water. You can see a wooden basin at the bottom on the left. They wash the obtained mud, gold-containing mud, and because of this action, which is called panning, because of the panning, the lighter minerals like clay escapes from the basin and enters into the water. And at the bottom of the pan, the basin, they get metallic concentrate. However, at this stage, the concentrate is not pure gold. It is a mixture of gold, iron oxide, and metallic sulfide. And they just want gold only, so they introduce mercury to mix metallic concentrates. Then, because of the mercury's chemistry to absorb gold, the gold is absorbed into mercury to make an alloy, which is called amalgam. And then they bring the alloy amalgam to a fireplace to set fire and heat it. In case of hard rock, first they bring big size of hard ore from the mountain, then they crush it into fist size, and then they introduce the fist size with water and mercury into this drum. This drum is called rod mill. Why? Because inside they install iron sphere or iron rod to crush hard rock. So anyway, they put water, mercury, and gold ore in this rod mill, and then they start rotating. And after a few hours rotation, they obtain a slimy product, which is a mixture of amalgam and clay and mud and sand. And again, they bring the slimy product into the water and then wash away the clay component, and then they get such gold amalgam. And for your information, this is a very dangerous practice. You can see that a miner is holding gold amalgam with bare hand without protection. Then he will absorb some amount of mercury through his artillery vessel, the small, tiny blood tubes. Mercury can be absorbed through your skin. So this is a dangerous practice. Anyway, this is how they they extract gold from gold ore. First, they make amalgam. Then what happens? On the next step, they bring this gold amalgam into a fireplace furnace. Such furnace can be found at road mill stations or at a convenience store in the Philippines. In the Philippines, they have many small convenience stores, which is called sari-sari store. And there you can easily buy mercury, although such trade is illegal. Anyway, you can get mercury easily, and also you can find such furnace quite easily at small shops. Then what happens? They set fire and start to cook amalgam. Then, because of the high vapor pressure of mercury, mercury can be released as vapor or fume quite easily, and the mercury ascends as a fume to the atmosphere. So amalgam burning often takes place at or close to miners' dwelling areas, even in the kitchen, because they want to hide their gold product, which means housewives and children are strongly affected by amalgam burning. Consequently, the communities inhale significant amounts of mercury vapor, and the vapor contaminates soil, vegetation, water, everything around the mining site. So this is what they are doing at gold mining area. I mean, informal or illegal gold mining area. Then our biggest problem is the mercury contamination. In order to control the mercury contamination, we need to answer these questions. Our questions are, number one, how is mercury left in one road mill station or in road mill stations? Or how much mercury is left in road mill stations? This is a question on spot level or spot scale. Our second question is, how is mercury high in gold producing area? This is a question on district scale. Then the third question, what is the rule to control the distribution of mercury on spot level, district, and regional scale? What are the parameters to determine the contamination? In order to answer these questions, I have visited several mining sites in Mongolia, in the Philippines, and in Indonesia. And today, let me share my information and experiences from the Philippines. Here, I'm showing you the Filipino archipelago. This is the main island, which is called Luzon Island. And this is their capital, Manila. And if you drive 1.5 days, you can reach famous gold-producing region, the province. This province is called Camarines Norte. So it is located on southeastern tail of the Luzon Island. And this is very famous for high gold potential. And you can find a lot of small-scale miners for gold. And in addition, this province is famous for farming rich agricultural products, which means the mercury contamination is of great concern. So let us visit the communities. When you visit mining communities, you can see such scenes. On the upper left, I'm showing you a picture of a typical rod mill station. Here you can see 2 rod mills and water pools to wash the slimy product after milling. And also you can find sacks which contains milled product. One sack typically weighs around 10 to 20 kilo. Okay, and this worker is scraping the slimy product to bring the product into the water pool for the panning. Because they put mercury from the milling stage, this slimy product already contains gold amalgam. So when they bring this product and pan in the water, they can get gold amalgam. Then after getting the gold amalgam, they bring it to such fireplace. Can you see a torch here? And so they cook amalgam to vaporize mercury as fuel and to get the gold on the bottom of the crucible. And obtained gold is called sponge gold. And the purity of sponge gold is around 90% to 97%. It contains a lot of impurities. Anyway, also you can find such shack or hut in the community. This is the depository of such sacks. So when they get excess amount of slimy products, they deposit in sacks like this. So this is a typical scene at ASGM communities. Okay, now I'm showing you a plan, a typical plan which shows structures in one mining area. Please be noted that this figure is not to scale. Anyway, in this village, it is called Barangay Santa Rosa Sur. In Tagalog, barangay means village. So this is the village Santa Rosa Sur. Anyway, in this village, they have one small hill. And at the foot of the hill, they have several structures like this, including a rod mill station, several water pools, and smelting room, fireplaces. In this case, they had 2 smelting rooms, room number 1 and room number 2. And in addition, they had a cyanide tank. So after milling the gold ore at this rod mill station, and after washing the slimy product in the pond, they bring the gold amalgam to the smelting rooms. Either room 1, room 2, it depends. Anyway, they use these smelting rooms to get sponge gold. Okay. And they recover the sediments, bottom sediments of these ponds, because the major component of the sediment is clay and mud, but it still contains some amount of gold, and they want to extract this gold. So they bring this sediment into the cyanide tank. And because of the chemical reaction of cyanide solution, they extract gold. And after the cyanidation, they got final waste, industrial waste. Actually, it is mud and sand. And the waste is called the tailings. And they bring the tailings into the so-called tailings pond. And because the tailings are heavily contaminated with mercury and cyanide solutions, this is the most dangerous place in the mining community. And we must know how to manage the tailings pond to control the mercury contamination. It is a very big issue, and we still do not have enough scientific information about this. So today I'm going to give you some information about this side, not about the tailings pond. But I think in the near future, I can release information about this tailings pond, because I have one new project which drills one tailings pond in Japan. Anyway, the UN bodies are well aware of the danger of the tailings pond, and UNEP's already published a technical guideline last year how to manage the tailings pond. And according to my view, the contents are not enough, but anyway, the tailings pond is a big issue now. Okay, let me go on to the next slide. Okay, this is a brief sketch of the smelting room number 1. I wanted to know how much mercury is left inside such smelting room, and I expected huge amount of mercury on the floor or on the wall. And in this room number 1, they had 3 abandoned furnaces and 1 active furnaces and 1 store and several oil drums covered with tarpaulin. And when I used a handheld XRF detector, surprisingly, I detected 9 ppm mercury only 1 point, and the other points showed no mercury anomaly. It was against my expectation. Then what about the room number 2? In this room, they had 2 active furnaces, and the 2 points close to these furnaces showed high amount of mercury, 87 ppm and 204 ppm. Okay, but in this room, I found a lot of broken crucibles. You mean, do you know crucible? Crucible is a heat resistance container with which they cook mercury, amalgam. And they are depositing abundant broken crucibles, a lot of crucibles here. So I measured those crucibles, and surprisingly, I detect my detector did not show anomaly. So what is happening? This is a rough sketch of a fireplace where miners cook amalgam. This is a torch. This is gasoline container. This is bellows. So bellows sends air and to the gasoline container. Then the gasoline is introduced into the torch, and they cook the amalgam inside this crucible. And surprisingly, again, I did not detect mercury in the crucible, but some amount of mercury on the lattice, wooden lattice, 30 ppm, and on a rug hanged on the lattice, 12 ppm. Okay. Then what about the air quality around the road mill stations. Here I'm showing you data at road mill station or the at smelting place, fireplace, and at non-mining area. And just after the amalgam burning, yes, indeed, we detected huge amount of mercury, 314,000 nanogram per cubic meters. However, at a furnace, which is 4 weeks after the amalgam burning, we detected only 7.8 nanogram per cubic meters. You can compare this figure with non-mining area. This measurement, 9.1 nanogram per cubic meter, was obtained at an open space of a restaurant in non-mining area. So surprisingly, the mercury concentration is rapidly decreasing in the road mill stations. So what is happening? Okay, and also I can show you the influence of mercury, the mercury concentration in botanical species. Here, the solid bars indicates plants growing closer to the road mill station, and this diagonal pattern means plants growing far away from road mill stations, and clearly the closer plants shows higher anomaly of mercury, and especially fern. For many years, mining people knows that fern is a hyper accumulator of metals, and in this case, in such area, fern absorbs a lot of mercury. And be careful, in this region, they eat young bud of fern, cooking it with shellfish and coconut. So we must give alert to the local people. But today I do not have time to talk about the risk management or risk communication. So let me just give you the information or the observation. Okay. Anyway, so what can we say from these observations? Mercury on spot or community level. Mercury is released from a furnace and it ascends rapidly to the atmosphere and does not reside inside the workspace much. Mercury from road mill stations is diffused mainly through the air and partly through the wastewater. These facts imply that mercury contamination does not spread in concentric circle pattern with a road mill station in the center. We need to identify accumulation points one by one carefully. Okay. Now let me go on to the discussion on district level. Here I'm showing you a satellite image. This is a bay which is called Murao Bay. And this cloud-like pattern means ASGM zones. So under this cloud, there are a lot of ASGM communities. And these solid white circles means measurement points and sampling points to know the effect of mercury. And the distance from the ASGM zone to the eastern shore of the bay is about 2 kilometers. Okay, so let me show you the information about air quality and also the mercury concentration in sediments, water, and suspended materials in water. Okay, here I'm showing you the air quality around this area. The orange bars indicates the air quality on eastern shore, closer to the ASGM zones, while the blue bars mean the western points, which is far away from ASGM zones. And you can see the significant difference between the eastern shore and western shore. And clearly, Mercury is coming from the ASGM zone. So at least we can say that at least Mercury can be transported through wind at the distance 2 or 3 or 5 kilometers. Okay. Then I'm showing you the analytical result of sediments from river and also estuary, and water and suspended materials, which was taken by using a syringe. So let us look at, let us review the sediment concentration. The gray bars means the concentration of river bed sediment. And the river bed sediment indicated highest amount of mercury. And the orange bars comes second, and the blue bars comes the third. Then what about water? What about the suspended materials? These medium also shows the same tendency. The gray bars indicates higher amount of mercury. So that means river is transporting mercury compounds. So for the moment, my team's notion is like this. From the road mill station, most of the mercury ascends to the atmosphere. Part of the mercury goes into river directly, but most of the mercury first ascends to the air and floating on air. And after that, by wind and rain, the mercury is redistributed to river, soil, forest, rice paddy, and so on. So before this study, on intuition, people imagined that the mercury contamination will be spreading like zonality or concentric circle patterns with road mill stations in the center. But the reality is not so simple. We need more complex model, which includes the parameters of weather and other dimension. Okay. And our last, the unsolved, and I still have unsolved the question. That is, what is the maximum distance of mercury transport? We still do not know about it. There's mostly no information about this. So my team will visit the Philippines again in next March and take some lake sediment samples at a distance around 100 to 200 kilometers. So we can know on a provincial or national level that how much mercury is transported from the mining site to such long distance, and what is the maximum transportation from the mining site. And I hope such new information can contribute to fine-tune the geochemical model of mercury contamination. Okay. Yeah, these Japanese data is just showing the Japanese standard. Okay, so this concludes my presentation. Thank you.